Hello everyone, so in this particular video we will be coding cross attention in PyTorch. So we'll start with our basic import. So we're going to import torch, we are going to import torch.nn as nn, and we will also need torch.functional. So we're going to say torch.nn.functional as capital F. Okay, so once you're done with that, we'll need some variables. So we're going to say number of heads because we are going to take as we are going to do multi-head attention. We have already discussed this in the previous video. Okay, then we'll also need let's say d of model, which is basically the embedding dimension. You can keep it like this also, embed dimension. Okay, or d of model, whatever, 512. Let's keep it there. Now one thing that I want to focus here is in cross attention. You need to understand that this only works, okay, mostly it works in when you have an encoder decoder architecture. Okay, that is where I have used mostly. Okay, so when you have an encoder, let's say this is a transformer architecture. Okay, this is where your cross attention will work. Now one important thing here is, let's take an example. Okay, so let's say you are doing a Hindi to English translation. Okay, Hindi to English, don't worry, if you don't understand Hindi, it's not a big deal. Okay, so let's say you're doing kaise ho aap, so this basically means hi, how are you. Okay, so if you want to convert this sentence in Hindi to English, what you will have to do, you will have to pass this entire thing to the encoder. Okay, because this is what you have and you want the English version of it. And in the decoder side, whatever is the current position, let's say you have already predicted the first three words and you are going to last predict the fourth word, you need to give the first three words and then give a dash. Okay, the decoder will be responsible for figuring out this word you. Now in cross attention, remember we are dealing with attention, which means different inputs will have different weightage. So just if you are going to predict the word you, okay, this particular word, which word does it correspond to in all of this, or where it should be, at which point it should be giving its most attention? It should be giving its most attention to the word app, because app corresponds to you over in this context. Okay, so if you're going to predict you, the word in context, or the word that is most important in this particular sentence, is the word app. Okay, so this is the entire logic, which means one thing that you need to understand is, remember, query, when we talk about attention, we talk about query, we talk about key, and we talk about value. What is the query? Query is a question, right? So query is coming from the decoder. Okay, query comes from the decoder. And key and value, where will come from? It will come from the encoder. So this is what I have mentioned over here. Query comes from the decoder, and key and value comes from the encoder. Okay, so this is all the theory you needed to understand. Okay, let's say the embedding dimension is, 512. Okay, let's go ahead. So sequence length of q, this is, remember, this is query, which means query comes from the decoder part. Sequence length is the maximum number of words. Let's just assume it to be 10. Okay, then sequence length of key and value. Okay, key and value comes from encoder. Let's take it as 15. Let's take batch size as 16. This you can change it. So what is the head dimension then? Okay, let's just let's say, what is the head dimension then? Head dimension is basically your embedding dimension divided by the number of heads, right? Because number of heads, basically head dimension is going to be, what is head dimension? Head dimension is going to be the number of let's say the number of values that is going to be attended in each head, on basically on which we are going to use our softmax function. Okay, so our head dimension should be, in this case I think it should be 64. Let's go and see what yeah, it will come 64. Okay, we have already seen this in the previous video, multi-head attention, so I'm not getting too deep into it. Now we need to have three things. Okay, so before that, let's have torch.randn. So this is going to be our input. Okay, so batch size, comma, you're going to have sequence length, and this is going to be, let's say okay, let's just put it this way. Okay, let's say we are going to have directly our vectors only, we are going to have directly our tensors. So sequence length q, otherwise it will take a lot more time and I don't want to get, because that is in transformers. When we'll talk about transformers, and then immediately next series we'll be talking about all that, but right now let's just focus here. Okay, and then finally embed dimension. Okay, so this is our query tensor. It's not matrix, it's query tensor right now. Okay, so basically this is not even this is the input to the to say your linear layers basically. So don't worry, I'll explain it in the next couple of lines. Okay, then we have key, same idea over here, only one thing will change. Instead q, because this was a query, this is now instead of qv I should have mentioned kv. Okay, so now it's correct. Finally, you are also going to have value. So these are all input that we will multiply with our to say our matrices. Okay, so let's go and hit shift and enter. Once that is done, you can print the shape of all of this. So query dot shape, then you can have key dot shape, and finally value dot shape. So let me just convert this to key dot shape, and let me convert this to value dot shape. And if you go and look into the to say tensors, this is 16 cross 10 cross 512. So 16 is your batch size, 10 is the 10 here is the number of sentences in the encoder, or sorry, this is in the decoder because query is from the decoder. Okay, and 512 is the representation of each word, so the dimension of each word here. Okay, now what we are going to do, we are going to have our query matrix. So query matrix is nn.linear, and we are going to have embed dimension cross embed dimension. Okay, so we are going to keep it very simple. Let me just remove this over here. Once this is done, instead of query we are going to have key, and same thing for the value, instead of q we are going to have v. So this is now here. So what is our query, final query? Query is nothing but q linear into the query. Basically this is your linear transformation. Okay, now for the key you can have k, and here also you'll have k. Same thing over here for v, so you'll have capital V over here and you'll have small v over here. Okay, you can do that and then print all the shapes. So q dot shape, okay, then v and k and v. So you're gonna have k dot shape and v dot shape. Yeah, one mistake that I did over here is instead of query this is going to be key and this is going to be value. Okay, this is very important. Okay, so value. Okay, so now if you hit shift and enter, and then over here if you to say this also, if you hit shift and enter, what you're going to see is you're going to see that here you got 16 cross 10 cross 1 5 15 5 12. This is also the same over here. Here also same thing, 16 cross 15 cross 5 and 2. Here also 16 cross 15 cross 5 and 2, and same thing over here, which means this linear layer, since this is same dimensions, nothing has changed, but these are key query, key and value tensors. Okay, that has come after the multiplication with the linear layers. Okay, now what you do is you can go ahead and then figure out our attention mechanism. Okay, but before that we need to do what so now what we can do is basically over here we'll have to figure out a way to divide this particular embed dimension into the number of heads. So what I'm going to do is, so let's say for qv, which is in a different shape, or q of view of q, we are going to say q dot view, and then you're going to have batch size, okay, -1. So whatever is left will come at -1. Number of heads, okay, so number of heads, and then finally head dimension. Now head dimension into number of heads is our embedding dimension, which basically means we are trying to divide our embedding dimension of 512 into these two things. Okay, same thing you're going to do with your key. So you're going to have kv, and here you're going to have k. Okay, again same thing over here, instead of q we'll have v, and here also v, and we are going to hit shift and enter. Okay, once that is done, okay, why this -1 and all that? Because we need to make sure that our shapes are taken well care of. So qv dot shape, kv dot shape, and then capital V small v dot shape. So if you hit shift and enter, basically you can see this embedding dimension, which was 512 over here, has now been splitted into 8 heads, and each head having 64 dimensions. Okay, let's go ahead. Now finally you want to transpose it, so I'm going to say q of t, where we're going to have q of v dot transpose. Why we are going to transpose and what we are going to transpose? We are going to transpose these two, which basically means we are going to transpose 1 comma 2. Okay, now again same thing, copy over here, paste over here, copy over here, paste over here. So here instead of Q we are going to have K, and here also K, and instead of thing we are going to have V, and here also V. Okay, let's do this and then finally have all our shapes printed. So Qt dot shape, and then we are going to have kt dot shape over here. So kt dot shape and vt dot shape. Let's hit shift and enter. So now you can see these two dimensions have been swapped, 8 and 10. So now you have 16, 8, 10. Here it was 10 and 8, and so and here it is 8, 10. Same thing here. Here it was this one 15, 8. Here it is 8, 15, and so on and so forth. Okay. Now what we are going to do is we are going to find the scores. So scores is we are going to have torch.matmul. So we are going to multiply both the tensors over here. Qt will be multiplied by kt dot transpose. This is going to be -2 comma -1. We need to, this is the key, right? This has to be transposed. 64 will come in place of 15 and 15 will come in place of 64. Okay, why we need to do this? This has already been explained in the previous video, so I'm not going to get into that. Finally, you are also going to divide it by head dimension root. So head dimension to the 0.05, so which basically means the divide by the root of head dimension. Okay, so we are going to have scores, and we are going to create shape of our scores dot shape. Okay, once we do that, you see over here we have 16 cross 8 cross 10 cross 15. Okay, once that is done, okay, what we are going to do now is we are going to figure out our attention weights. Now attention weights is f.softmax, and we are going to pass in the scores and dimension equal to -1. Okay, and then finally you're going to see what is the weights. So attention dot weights dot shape. Okay, so we're going to have, this is going to remain the same. Why? Because softmax does not change the dimensionality of anything. Okay, finally you're going to have the output. So output is equals to torch dot matmul. So you are going to do matrix multiplication of attention weights, attention underscore weights. Okay, and you're going to multiply it by vt. Okay, so once that is done, you're going to just print output dot shape just to see what the output is. Okay, so finally you'll go get the output as 16 cross 8 cross 10 cross 64. Okay, so now we have that. Okay, so 10 was for to say your query, which means the decoder. So finally we have gotten the output over here because we are doing cross attention. Now what we are going to do is we have to merge these two back, right? We have to merge 8 and 64 back. In order to merge 8 and 64 back, we have to transpose this one more time. Okay, but the way I am going to do it is I'm going to say output is equals to output dot contiguous GUOUS contiguous dot view. Okay, so first I'll have to transpose dot transpose minus 1 and 2, which means this 10 again will come back over here, and this 8 will come in place of 10. Dot view batch size dash -1 into d of model. Okay, and then finally instead of d of model we are going to have embed dimension, and then finally output dot shape. So let's do this, and the answer finally comes back to 16 cross 10 cross 512. So this was the entire thing about cross attention. You need not worry, the code is already there in the description. It will be uploaded on GitHub. So if you like the video, please like and subscribe. Thank you very much, and bye.